Morning. Today's lecture is chapter 8, Geology and Geologic time. The first part of the lecture will be something like a quick revision. It will help us in our next exam. Just a reminder, why are we studying geology? We are studying geology to help us in geotechnical engineering. And why are we studying geotechnical engineering? Just a reminder with this photo that we are studying geotechnical engineering to save lives. This to save money and maybe life. So geotechnical engineering is very important for us in both ways, saving lives and saving money. This is something important also as a revision. What is the relation between science and geotechnical engineering? Science, I mean by science, geology and hydrology. Geology and hydrology are the base of geotechnical engineering. What is the difference between a geologist and the difference between a geotechnical engineer? A geologist is a scientist. He is studying science. So science studies all the problems around us. Geotechnical engineering proposes the solutions for these problems. A geologist will tell you that there will be an earthquake in this area, or there was an earthquake in this area. He will give you the intensity, why it happened, everything, all the data for this. But he's not going to give you any solution how to build a building that can carry this earthquake without problems. Who can do this? A geotechnical engineer. How can he do this? By analysis of the data given by the geologist or by geotechnical engineers, of course, designing buildings that can carry this earthquake, as an example, and then constructing these buildings. So this is the relation between geologist and geotechnical engineer. Now, let's go into some general information. We are studying geology. Why are we studying geology? What are the type of data that we are going to study? Let's just categorize these data. These data may be something that is important for everyone, not especially engineers. When we speak about earthquakes, volcanoes, tsunamis, we all of us speak about this because we face these features all over the world. So all people should know these basic ideas about these features. So this type of data is important to all people. It's not only important to engineers, to geologists, to geotechnical engineers, important for everyone. There is data that is important only to civil engineers, like information related to weathering, information related to climate. These are specific for some types of engineers. So this type of data is required, but it is required by some types of civil engineers. There is data that is important for geotechnical engineer, for us. Why this data is important? Because it affects the type of building that we are going, or the structure that we are going to build on top of this soil. Data about what? Maybe you've seen in the lecture of faults. You know what is faults? We said faults اللي هي in Arabic الفوالق. Of course, if I am going to build a building and I know there is a faliq or a fault next to my building, I will go away from this building. So, or I will take my building and build it in another place. Fold is something like fault, but fault means that the layer was splitted into two. But fold means that the layer was twisted. So, of course, building a building on top of a fold may require some additional precautions. Dikes. We've seen dikes, photos for dikes, but it helps us mainly in understanding the boreholes that we perform during site investigation and so on. So these are examples of data that is important to geotechnical engineer. Then there is data that is important to geologists. Of course, this data, as I said, it is important for geologists, so it's not that important for geotechnical engineer or civil engineer. What is similar to the history of the earth, minerals, how they were formed, and how engineers care for strengths. They care for why. What is the strength of this material? By the way, this is important. This may be one of the questions that you may face in any exam. Why is this data important? Why we are studying geologic data, geologic information? Because some of the information are very important to us as engineers or as geotechnical engineer, and some of the data are not important. That's why in our syllabus here, we try to concentrate mainly on the data that relates to us as engineers as a minimum. Or even the data that is important. This lecture, the lecture of today, is important not for engineers, it's important for everyone. Everyone should know this basic information about the earth that we are living on. We should be only targeting 1, 2, and 3. So 1, 2, and 3 are important for us, but number 4, which is the data that is important to geologists, we should try to avoid, because it will be complicated for us to understand, and we will not benefit a lot in our professional work. Why do engineers study geology? Why do I study geology? There are few points that are categorized the importance of this study. The first thing is something related to economy, what it is. We use soil, rock, water, metals, minerals, industrial minerals, energy. All of this we use in our daily lives, in our industry. So if we study this, then we may go to have some cost benefit from using it. I know the strength of the material, I know the quality of the material, I know how to get this material. So by studying these types of material, I will save money or gain money. So this is the first thing. So why do engineers study geology? First thing related to economy. The other, to study rocks and fossils. To study the rocks and the fossils they contain, to understand the evolution of our environment and the life within it. So something like understanding that this continent was not in this place millions of years ago. Of course, I'm not just targeting where did the continent go, but I'm targeting how the rocks and the material that I'm going to put my building on top of it was formed. So this is something like an information. It is important information. Of course, it will not affect my design, but it is like knowing the history that is related to what I'm going to use in my design. To learn to minimize our risk. Like when I study earthquakes, of course, this is very important. Earthquakes, volcanoes, slope failures, all of the photos that you have seen for failures, all of them are related to features like this. So if I study them good and I get out the benefit from studying them, then I will minimize the risk that would happen to me. To learn how and why Earth's climate has changed in the past and use that knowledge to understand both natural and human-caused climate changes. Climate changes is related to some types of engineers, or even to if I'm building a building in a place, so I need this building to be matching with the environment around me. So it also we can say that it is part of the basic information that we need to understand before we design our buildings. What is geology? Of course, this is basic. This, you can consider this a revision for what we have said before. Geology is the science of Earth, dealing with its composition, structure, and geological history, as well as studying the origins, properties, and compositions of both rocks and minerals. Of course, you don't need to memorize this, but you need to understand what is geology. If I tell you what is geology, it may be one of the questions that you may find in any exam. What is geology? How to differentiate between geology and geotechnical engineering. Geology also studies the Earth's history since its birth 4.5 million years ago, and studies the processes that have shaped the Earth's surface, ocean floor, and the interior of the Earth. It is very important for me to know that the Earth, when it was first created, it did not look like what we see nowadays. It changed. Knowing how it changed help us to understand how it is going to be modified in the future, or how it reached this current situation. So this is the definition of geology. We said here that we know how the Earth was shaped. To know how the Earth was shaped, then we need to know few terms. These few terms are very important because also they may be questions. What are endogenic forces? What are exogenic forces? We took this before. Endogenic forces are the forces that is coming from the bottom of the Earth. Exogenic forces coming from the atmosphere to the Earth. What are these forces going to do? They are going to shape the Earth. Of course, I need to know this to know how the shape of the Earth has happened. We'll take the endogenic, the forces that is coming from the interior of the Earth. We said that they are called constructive forces. Why are they constructive forces? They are constructive forces because they construct the Earth. They add layers to the Earth. If forces help in adding layer to my Earth, it means that I'm constructing the Earth. But what are these? They are divided into two main categories: fast process and slow process. The fast processes earthquakes and volcanoes. And I said this is very, very important. Volcanoes are destructive, but in geological meaning they are constructive. Why constructive? Because they add to the Earth. But earthquake really destruct my structures. So they destruct my structure, but they construct my Earth. So this is how both are fast processes. Slow processes, something called isostatic equilibrium and plate tectonics. Isostatic equilibrium means the plates going up and going down. Plate tectonics mean the plate moving horizontally, either bombarding with each other or just pushing each other, or going below one another. Plate tectonics mean, or even leaving each other. If I have a plate that is split into two plates, like what we said about India. We said that India was once part of Africa, but it moved from Africa and reached Asia, collided with Asia, causing the ejection of the Himalayas. This is all plate tectonics. So this was the endogenic forces. What is the exogenic forces? By the way, so far all of this is a revision for what may be included in your next exams. We are not taking new information so far. Exogenic forces means external forces, and we said that these external forces are destructive. How are they destructive? Examples of these forces are weathering, mass wasting, and erosion. This we took in a very near lecture. Weathering, التحلل أو يعني the material disintegrates into smaller particles. So this is destructive, because if I have a big material and I leave it to weather for millions of years, it will be may end up with a very small material. So the material has been destructed to be this small portion. So weathering is a way to form of course I'm not speaking about small material, I'm speaking about mountains, plates, and something like this. So weathering is one of the destructive exogenic forces. Mass wasting is similar to weathering, but weathering means that the material is just disintegrated, but mass wasting means blocks of this material split and leave the original big bulk. Then we have erosion. Erosion is related to weathering, because weathering means disintegration, but erosion means taking the disintegrated material away from its original place. How can we take it? We take it by wind, we take it by water, by rain, by floods, by anything. So erosion is the transportation of the weathered material from one place to the other. Geologic structures of the earth. Structures are variations or shapes or properties of the earth crust. Geologic structures, something like what we've studied before, folds, faults, what are inside the earth from inside, how the plates behave. So we have two ways for shaping these plates. The first is called primary, and the second is called secondary. The primary means non-tectonic. So it is not affected by the movement of the plates. But tectonic means it is affected by the movement of the plates of the earth. So what do we mean by primary? Since the start of the earth, primary structures occurred. How they occurred? The formation of the sedimentary rock is an example. The formation of igneous layers of rock is an example for that. If I have igneous rock coming on top of the earth, adding a layer on top of the earth, this is a primary way for formation of the rock. But tectonic or secondary means that due to the forces on the plates, compression forces on tensile forces, so these plates change in shape. Starting from here, this is the new part in our lecture, the geologic time scale. Imagine that I drilled a hole from the surface of the earth to maybe kilometers below, and I got samples outside. If I take these samples, the sample that will be at the bottom is the sample that was formed maybe millions of years ago. And the sample that is formed on the top, on the crust, is the sample that was formed in the recent maybe 100 years ago. So it really gives me the history of the Earth. So geologic time scale is a calendar of Earth's history which divide geologic history into units. So scientists divided these layers into periods of time. زي ما بنقول كده in Arabic العصر الجليدي، العصر مش عارف الحديث، العصر ايه. So the scientists divided the earth into periods of time. Very old periods, we know them, and very recent period and intermediate and so on. So they divided the earth into 4 main periods. The first is called Aeon, the second is called Era, the third is called Period, the fourth is called Epoch. We will see this in this photo. By the way, you just know it as an info. You are not supposed to memorize all of these, but maybe when you read this, you may find something that you have heard about. Maybe some of you have heard about something called the Cambrian age, or Jurassic. You have heard about a film called Jurassic Park. What is Jurassic Park? What do we mean by Jurassic? Jurassic, this is a period of time. Jurassic does not mean dinosaurs. It means a period of time. But during this period of time, there was special type of dinosaurs. So when I say Jurassic Park as a film, it means that I am facing, whoever created this film is imagining that he is facing creatures coming from this Jurassic period of time. So it helps us in understanding terms and words that we hear. So look at this. This is the column. Here is Jurassic. So it is something intermediate. It was not at the beginning of the formation of the Earth, and it is not recent. And so on. These are the definition. These are, first we have Cambrian, Precambrian, and so on. These are all periods of time. A similar way for presenting it, but it will help us in understanding some wrong information that we used to see in films. Usually in films they show you a creature like a big dinosaur with flares coming from his mouth facing a human being. It's not possible, because dinosaurs were on the planet. They were extinct before the first human being came to Earth, so they did not meet. It is impossible that you find man with a dinosaur. Dinosaurs were in this period. During the period of where men and women were there, the maximum, the biggest creature was a type of elephant, the mammoth. You know, some films show you the mammoth. Okay, this is accepted, but to meet a dinosaur, it is not possible, because the difference is millions of years apart. From here, this is the new information in this lecture. The new information is something called unconformity. Unconformity means what? Imagine that you have layers of soil like this. These are the layers of rocks and soil and so on. And these layers are subjected to forces, shaping forces. These are the internal forces that are shaping the layers. So if I have compressive forces like this, so my layer will be twisted something to what you see here. Imagine that by erosion, this part on top of this dotted line were swept away. So this what will happen, this we call the erosion surface. So the surface was eroded till reaching to this layer. What will happen on top of this surface? Later, new layers will be formed. So this is exactly what is happening. This is the erosion surface, and this is the previous layers, and now these are new layers that were deposited on top. So what will happen to this layer? There will be a line of separation. Actually, this line of separation means that there is a gap of millions of years between each other. It's not like, if I tell you that here there is a line, this line means that the difference between the layer here and the layer on top, they are consecutive. There is no gap between them. But this line, this unconformity line, means that there is a very big gap between the time of this above and this below. Here you will find that it is called Sicker point. What is Sicker point? Sicker point, of course, what you see here is something that is found below the earth. I cannot see it. It's just expectation for scientists that this has happened, or geologists that this has happened. But geologists feel very happy when they find a feature like this that they can see. So this is exactly what happened. Let's see how it happens first, and then let's see it in normal life. Imagine that this is layers A, B, C, D. This is the first layer, second, third, fourth. These are consecutive layers. Then, due to horizontal compression forces, these layers tend to bend. When these layers tend to bend, later there will be some kind of erosion. Once we have erosion, the top part of these layers will be eroded away. Later, after the erosional period, there will come a new period where we have new depositions, new layers like this formed on top of our previous layer. So this line between the old layers and the new layers is called an unconformity. This is in a simulation for normal life. This is the original layers, then it got compressed, then it got eroded, then new layers are formed on top. So this is the unconformity line, or the separation between the old and the new. This is in normal life. This is an old, but by the way, this feature is very important. People may travel kilometers to see this feature because it proves their expectation for what happened to the earth. Without any description, if you just look at this photo, you will find that this was once the original layers. Then they got compressed by horizontal forces, so they bent it like this. And then the top part was eroded. then new layers were deposited on top. So this is unconformity. This is the same in another place, the same feature in another place. This is Sicker Point. What is Sicker Point? Sicker Point is very famous in UK, and anyone who is studying geology needs to know few famous names and few famous features. So this Sicker Point is very important. You have here, usually the formation of layer is usually horizontal, but in our case here, layers are nearly vertical. How come layers are vertical? By no means layers are formed in a vertical way. They may be formed a little bit inclined. We may accept this, but with a small degree. But to have layers 90 degrees, it is impossible. This is due to bombardment or collapse or collision between two layers, ended up with having one layer as if it is twisted 90 degrees. So these layers are all about approximately near 90 degrees. So this is the original layer. Then on top of it you will find this nearly horizontal inclined layer. So this is very famous. It is in Scotland. It is called Sicker Point, and Sicker Point was very, very important because a scientist called Hutton, he was expecting this feature, but he could not prove it. Then during his expeditions around the world, he saw this, and he came with all other scientists, and they saw this feature and they documented it. So he proved his theory, what happens to these layers. So this is a very, very important feature. Scientists divided unconformity into 4 types. The first type is called disconformity. Disconformity means this is sedimentary rock at the bottom, then the top surface got eroded, having this line, erosion line, then new horizontal sedimentary layers were sedimented on top. So this ends up with having horizontal sedimentary layers at the bottom, plus horizontal sedimentary layers on the top, and in between you can find this erosion line, and this is called disconformity. Disconformity is very easy to find. Why? Because of course there are easier unconformities to find, but disconformity is a little bit easy. Why it is easy? Though we have sedimentary on top and sedimentary on bottom, but the separation line is not a horizontal line. It is a line with lots of distortion. So it is very easy to find. The other type of unconformity is called paraconformity or parallel unconformity. Actually, this is very difficult to find. Why? Because the line of separation is parallel to the top and bottom layers. So really, if you are doing a site investigation and taking boreholes, you will not find any difference. The only difference can be detected by specialized geologists. Why? Because he will tell you that this type of rock belongs, say, to this age. He will tell you that this type of rock at the bottom belongs, say, to this age, and then it is followed by a rock in this age. So there is a gap. Many millions of years that are not available. How come they are not available? They were eroded before. So this is the problem of this parallel unconformity. Here, this is the parallel unconformity. It is very difficult to detect. They just check the type of rock, check the fossils that they can find. Maybe here they will find fossils for dinosaurs, and here they find nearer fossils, and so on. The third type is called non-conformity. Non-conformity, the difference between non-conformity and disconformity is disconformity is between two sedimentary rocks, but non-conformity, here you have igneous or metamorphic rock followed by sedimentary rock. So the type of the rock is differentiates between the two. The third is very easy to determine, which is called the angular unconformity. So here I have sedimentary rock, but it was angular. It was subjected to very big movement, so it was tilted. Then it was eroded and followed by horizontal layers. So this slide just summarizes all of what we have. We have disconformity, we have paraconformity, which are the parallel ones, we have angular unconformity, we have non-conformity where the underlying layer is not sedimentary. So this is a summary for this. This is, by the way, very important to us as geotechnical engineers. Why? Because if I am performing a site investigation and I take a borehole here and I take a borehole here, I can expect what to find. And by the way, this will be one of the questions in most of the exams where I tell you, I give you few boreholes and I tell you, imagine what would be the shape of the layers between these boreholes. If you don't understand what we've studied here and what we have studied before for folds, and dikes and so on, then it will be very difficult for you to understand. And this, by the way, it does not need you to memorize. It means that you, if you answer, it means that you understand what is geology. This is, we've taken before Sicker Point. Sicker Point, we said that it is an example of unconformity. A better example for unconformity is something called the Grand Canyon in US. The Grand Canyon includes many unconformities. It is not just one point, because if you look at Sicker Point, let's just remember Sicker Point. This is Sicker Point. We have here this unconformity line, because here we have inclined layers, and here we have nearly vertical layer, and here we have just nearly horizontal layers, and this is the separation line. But in this case, we have lots of cases. Just try to concentrate in this. This will be the end of the lecture. Here we have we don't have sedimentary rock. We have igneous rock. Here, this bulb and maybe something around it is just igneous rock. And here we have a separation line with inclined type of rock. So at the very early start, this was the original rock that was there. And then later it got eroded. And then when it was eroded, new layers were sedimented on top. These layers were horizontal, but with time they got a little more inclined. So this is called nonconformity. If you refer to where is the nonconformity? This is the nonconformity. Nonconformity is the separation between igneous or metamorphic and sedimentary. So this is the first type. So this is a nonconformity line. Here we have inclined layers with horizontal layer. So this is another type called angular. So here, this is the angular. This is sedimentary and this is sedimentary, but this is inclined and this is horizontal. It is exactly what you see here, inclined with horizontal. Then we have these separation lines. All of these are disconformity, referred to again to what is disconformity. Disconformity is separation between horizontal sedimentary and horizontal sedimentary, but this belong to age and this belong to another age with a gap between them. So this is another type. So this is very important. You have disconformities, you have angular unconformity, you have nonconformity, all of them in one place, and you can see it. So that's why Grand Canyon is a very good example for that. This is another presentation for the Grand Canyon. Here granite, it means that this is igneous. Here sedimentary rocks, but they are inclined, meeting with sedimentary horizontal layers and so on till the top. This is, now we are trying, now we finished the information about geology. Now we go to geotechnical engineers, to be geotechnical engineers. As we said at the beginning, we start with doing some site investigation. Site investigation means that we are taking few boreholes. Few boreholes will give me an indication for the soil here and will give me an indication for the soil here, or the layers of the soil and rock here. Can I expect what is in between? Usually I cannot expect. Maybe the layers are going up, going down, curved up, curved down. I don't know. But if I have some geologic backgrounds and I know the features and I've studied the area and I know what happened in the past, then with very few numbers of boreholes, I can expect what is in between. So this is exactly what is happening. Imagine that I have a case of a dike. This is a dike. What is a dike? A dike means that there was a separation in the rock, and in this separation, igneous rock from below came to fill this separation. If I have a borehole here and a borehole there, I will not be able to judge what is happening. If I add a borehole in between, then this borehole in between, imagine that you have this is the first borehole and this is the second borehole. This is the result, layer 1, 2, 3, 4, 5, and similar 1, 2, 3, 4, 5. You will never imagine that there was a dike in between. So if I add a borehole, then I can check this dike. If I do some I told you that there is another type of investigation called geophysical investigation. If I do geophysical investigation similar to the ultrasound you do on your stomach and to check if you have a problem in your stomach, so I can just do this superficial ultrasonic tests on top of the earth to decide what is in between. So this is the case of the dike. Imagine that you have a case of anticline. Anticline means that you have layers bended to the top. If I have a borehole here and a borehole there, they will be similar, exactly similar. So you will imagine that you have horizontal lines, but actually they are not horizontal, they are curved. Adding a borehole in between will decide, or doing geophysical tests will decide. If I have something like this fault or double fault which is a graben, if I have something like this, I will check here and check there. I will never discover the fault. But if I have additional boreholes in between, I can check. So to end the lecture, if I have a site investigation, I have, say, few boreholes, and these are indicative results of the boreholes. If I want to be more accurate, first I have to study geology. If I study geology, I will have the background to judge what is happening in this area. So if I study geology, I will be able to judge. Another thing is to use additional boreholes. If I do more boreholes in the middle, then I will be able to check how is the formation going. If I use geophysical methods, then I will know what is happening. Another thing is to inspect the surface for possible features. If I just go around the site, maybe I would find some, maybe tilt, if I have inclined layers here, and these inclined layers are reaching the ground, I can see it by my eyes, so it will be very important for me to judge what is below. So inspecting the surface, studying geology, doing additional boreholes, doing geophysical methods will help me to understand. So actually this figure and these previous slides just generalizes why we were studying geology if we are geotechnical engineers, because by studying geology and knowing all the features that you have studied, you can judge what is happening in any site investigation, and it will be very easy for you. We'll stop here. This ends up our lecture. Thank you, and see you next lecture.